Hi! Our lesson for today is all about systems of linear equations with fractions and parentheses. So for our first example, let's solve 2 times the quantity of x plus 1 plus y minus 3 is equal to 4, which is our first equation, and 5 times the quantity of x plus 1 minus y is equal to 0, which is our second equation. For our solution, let's simplify the first equation, which is 2 times the quantity of x plus 1 plus y minus 3 is equal to 4. So from here, it will become 2x, which is 2 times x, plus 2, which is from 2 times 1, and then plus y minus 3 is equal to 4. Then after that, let's combine similar terms. So we're going to transpose positive 2 and negative 3 to the right side, and then it will become 2x plus y is equal to 4 minus 2 plus 3. And then it will become 2x plus y is equal to 5. And this will serve as our third equation. Now, let's simplify our second equation, which is 5 times the quantity of x plus 1 minus y is equal to 0. So from here, we're going to apply the distribution property. Okay, so we're going to multiply 5 times x. It will become 5x, and 5 times 1, and it will become positive 5. And then bring down minus y is equal to 0. And then from here, we're going to transpose positive 5 to the right side, and it will become 5x minus y is equal to negative 5. And this will serve as our fourth equation. Now, let's add our third and fourth equation. So our third equation is 2x plus y is equal to 5, and our fourth equation is 5x minus y is equal to negative 5. And if we're going to add this, 2x plus 5x, it will become 7x, and then positive y plus negative y will become, or it is equal to 0. And then positive 5 plus negative 5 is equal to 0. And then let's apply the division property of equality by dividing both sides by 7. 7 divided by 7 is 1x or x, and 0 divided by 7 is equal to 0. So therefore, the value of our x is equal to 0. Now, let's substitute 0 for x in our third equation, which is 2x plus y is equal to 5. If we're going to substitute the value of x by 0, it will become 2 times 0 plus y is equal to 5. 2 times 0 is 0, and then bring down positive y is equal to 5. So therefore, the solution is the ordered pair 0 and 5. Now, let's check if our solution 0 and 5 is correct. Let's use, or let's substitute 0 for x and 5 for, for 0 for x and 5 for y in equations 1 and 2. So for our first equation, we have 2 times the quantity of x plus y minus 3 is equal to 4. Then let's substitute the value of our x and y. So we will have 2 times the quantity of 0, which is the value of our x, plus 1, plus 5, which is the value of our y, minus 3 is equal to 4. Then it will become 2 times 1, which is it came from 0 plus 1, and then 5 minus 3 is equal to 2. So 2 times 1 is 2, and then plus 2 is equal to 4. So therefore, 4 is equal to 4. So using the first equation, we prove that the solution 0 and 5 is correct. Now, let's use the second equation, which is 5 times the quantity of x plus 1 minus y is equal to 0. Now, let's substitute the value of x by 0 and the value of y by 5. So it will become like this. And after that, 0 plus 1 is 1. And then 5 times 1 is 5. Minus 5 is equal to 0. So therefore, 0 is equal to 0. So it proves that the solution 0 and 5 is also correct by checking using the second equation. Now, for our second example, let's solve the system x over 5 plus y over 4 is equal to 12, which is the first equation, and x over 3 minus y over 4 is equal to 4, which is our second equation. So for our solution, let's multiply both sides of the equation or the first equation by 20, which is the least common denominator or the LCD of the fractions. Now, so, so 20 times x divided by 5, we will have 4x, and then 20 times y divided by 4 is 5y, and then 12 times 20 is equal to 240. So therefore, we will have the answer of 4x plus 5y is equal to 240, and then it will serve as our third equation. Now, for our second equation, which is x over 3 minus y over 4 is equal to 4, let's multiply both sides by 12, which is LCD of the fractions. So from here, so 12 times x divided by 3, we will have 4x. 12 times y divided by 4 is 3y, and 4 times 12, we will have 48. So we will get the answer of 4x minus 3y is equal to 48, and this will serve as our fourth equation. Now, let's subtract our fourth equation from our third equation. So 4x plus 5y is equal to 240. Then minus 4x minus 3y is equal to 48. So now let's subtract. 4x minus 4x, we will have 0. And 5y minus negative 3y, we will have the answer of 8y. And then 240 minus 48, we will get the difference of 192. And after that, let's divide both sides by 8. So 8 divided by 8 is 1y or y, and 192 divided by 8, we will have the quotient of 24. So the value of our y is equal to 24. Now, let's substitute 24 for y in our first equation, which is x over 5 plus y over 4 is equal to 12. Now, let's substitute the value, and then so 24, we can simplify 24 divided by 4 by 6. So we will have x over 5 plus 6 is equal to 12. And after that, let's multiply both sides of the equation by 5, because that is the LCD of the fractions. So 5x divided by 5, we will have 1x or x, and then 5 times 6 is 30, and 12 times 5 is equal to 60. And then let's transpose positive 30 to the right side. We will have 60 minus 30, and then therefore, the value of our x is equal to 30. Then, therefore, the solution is the ordered pair 30 and 24. Now, let's check if our solution 30 and 24 is correct by substituting the value of x by 30 and the value of y by 24. Let's check first using the first equation. Again, our first equation is x over 5 plus y over 4 is equal to 12. Let's substitute the value of x and y. So we will have 30 over 5 plus 24 over 4 is equal to 12. And if we can simplify, 30 divided by 5 is equal to 6, and 24 divided by 4 is equal to 4. And then 6 plus 6 is equal to 12. Therefore, 12 is equal to 12. We prove using the first equation that the solution 30 and 24 is correct. Now, let's use the second equation, which is x over 3 minus y over 4 is equal to 4. Let's substitute the value of x by 30 and the value of y by 24. 30 divided by 3 is 10, and then 24 divided by 4 is 6, and then 10 minus 6 is equal to 4. So therefore, 4 is equal to 4. We prove also using the second equation that the solution 30 and 24 is correct. I hope you understand our lesson for today, which is systems of linear equations with fractions and parentheses. Again, this is your friendly math teacher, Sir Cielo. Thank you for watching. Bye!